In this video, I want to give you an overview of what's called a MIG welder. It's a kind of electric arc welder, and the word MIG is an acronym. It stands for Metal Inert Gas. It is actually the easiest welder for beginners to use. I'm not a professional welder, but I've been welding on and off for more than 30 years, and the MIG welder's the thing. If you want to get involved in hobby welding, this is just the ticket because it's so easy to use. So, as I mentioned, it's a kind of electric welder, which means that it forms an arc, and the arc, during use, as you'll see, travels from this little wire here to the metal workpiece. And the reason it travels to the metal workpiece is because it wants to complete a circuit. This is called a ground cable, and it also connects to the metal you're welding, and it provides a path for the electricity to flow. So there's an arc jumping in the airspace between this little wire and the metal you're welding, and that arc creates heat. And something else too, one of the important features of the MIG welder is that it automatically advances new wire into the weld. So this is just sitting here right now, but if I were to turn it on, it's going to boot up in a second, you'll see that that wire actually extends on its own. I'll just press it for a second and you'll see. Now, the reason for that is because most welding involves adding new metal to the joint that you're connecting, and this happens automatically with the MIG welder. The wire comes out. You can adjust the rate at which the wire comes out, as well as some other parameters on the machine, but this automatic wire advance is one of the reasons MIG welders are so easy to use. It's also why they're sometimes called wire feed welders, because they're feeding the wire in automatically. But let's go around to the front of the machine now, and I'll show you a few parameters and how this machine is adjusted and used too. There are two main parameters when it comes to a MIG welder. One of them is voltage. You can see that here. I'm doing some welding right now, welding some steel pipe. It's about 1/8 of an inch wall thickness or so. And as it turns out, a 17.4 volts is what I want. Now, voltage on a MIG welder translates to the intensity of the arc. Now, you want that arc to be intense enough that it melts metal on both pieces that are being joined, but not so powerful that it actually blows a hole through the metal. So you can see here, all MIG welders allow you to control the voltage. Now, I'm in the green zone here because I have, as I'll show you, pre-programmed this machine for the kind of metal that I'm welding. So it's giving me a range of voltages, so I can safely go from 16 volts to 18 volts. This would be too much. That would be too little, given the metal that I've told the welder that I'm welding. So voltage, one parameter. Now the other parameter is inches per minute of wire feed travel. So once again, I have a range. I'm 261 here, 310 on the top end, and 210 on the bottom end. So 261 is about right. In practice, and I'll get into this more in subsequent videos, but in practice, you want a balance between the two. It doesn't have to be an identical balance each time. Sometimes you can crank up the heat voltage more. Sometimes you want a little more wire feed. But those are the main two parameters that all MIG welders need to be adjusted for. Now, how you adjust is different from machine to machine. This is fairly sophisticated, and it's got a digital control, so it's basically infinite control over those two parameters. Less expensive machines, you kind of have a preset level for the voltage and wire feed rates. Another big thing you need to realize when you're talking about MIG welders is the two different modes that you can MIG weld in. One is using shielding gas, and the other is using what's called self-shielding wire. In both of those cases, it comes down to the simple physical fact that when an arc is occurring, the metal, of course, involved is molten. It's very hot, way too bright to look at with your bare eyes. And in that state, in that heated state, it becomes very reactive with oxygen. So you can get what amounts to a very fast rusting right in the weld pool area. And you're going to get a terrible weld. There's just no way around it. If oxygen is allowed to encounter the molten weld pool, then you're going to have a bad weld. So there's two solutions to that. One solution is the configuration that I have my machine set up here, and that's to use an inert gas. So inert means that it doesn't react. An inert gas that floods over the weld zone while it's molten, and it displaces the oxygen. So it protects the weld from oxygen for that second or two that it's molten as you move along when you're welding. So in addition to the wire that comes from a spool inside the machine, I will show you that in a minute, there's also gas traveling through this cable. It's a pretty sophisticated cable, really. The gas flows out of these holes here. I've taken this shroud off. The gas flows out of these holes and out the end of the nozzle, which you can see is kind of hollow around the outside, and that gas protects the weld. So this is a blend of argon and carbon dioxide, and this is the shielding gas of choice for welding mild steel. If you're going to be welding other metals with the MIG welder, you might have to change and go for a different shielding gas. Now, it's kind of a complicated thing, though. To have shielding gas, you don't just need the welder, you also need a regulator and a hose, and you need the tank. Where I live, these tanks aren't available to own. You have to rent them. They're about $100 a year, and it costs about $100 to fill this tank up. How long does it last? It's hard to put your finger on it, but fairly long, we'll say, because there is a lot of gas in there. But it's still a hassle, and you have to pay more for a machine that can operate with shielding gas. So there's another alternative. You don't have to use any gas at all, and the wire that's used is actually hollow. And inside the hollow of the wire is a substance that, when it's heated and burns, I guess, while the arc is generating some heat, it creates a shielding cloud around the weld zone. Now, it's a little bit smoky. There's no smoke when you use something like this. It's a little bit smoky, and the results aren't quite as good for shielding. So the weld is not going to look quite as good, but it's still going to look pretty good. And there are many people, hobbyists especially, who just use the self-shielding wire. They keep things simple, no gas, no tank rentals, no regulator, and it works just fine. It's not an issue of strength, really, it's an issue of appearance. The weld is going to look nicer, neater, smoother, more controlled when you use the shielding gas. So now I want to show you inside. All MIG welders have an inside of some kind or another where the spool of wire is stored. So this is just straight wire, as I said, because it's designed to be used with the shielding gas. It's 25/1000th of an inch in diameter. This machine can use 25 thou, 30 thou, 35 thou, even larger, I think, in some cases. But I find that the 25 thou to be good for small welding. The bigger wire is suitable when you have to deliver more metal to the joint, so a bigger joint. Now the self-shielding wire, because it's got that little space in the middle, is larger than 25 thou. It's 35 thou, but it doesn't deliver quite as much metal as a regular 35 thou wire because it's got that shielding gas stuff inside of it. But let's just switch on here and I'll show you how it works. So the spools come large, like this, or smaller, whatever you like. And as soon as I pull the trigger, there's a motor feed in here that's going to start drawing the wire off the spool and pushing it all the way through the cable. So you see that's the way it works. Now, the speed at which it draws wire through the mechanism is controlled by that wire feed knob I was telling you about before. And if I wanted to change the wire, or if I ran out of wire, I would loosen this off. This comes apart like this, and you can see the drive mechanism in here. It's pretty clever, really. see, there's the drive wheel. Now this wheel here, if you can see, it's got a little groove in it. That groove is suited to this size of wire. So if I was changing wire diameter, I'd need to take this off, replace it with one that has a slightly larger groove. The actual driving happens up here. This, you see there's a gear here. The gear engages the other side of the gear right here. There's a motor drive in there. And this surface of this top disc is what drives the wire through. Doesn't seem like it should actually work, does it? I mean, pushing a little wee wire like this all the way through a cable that could be bent or twisted as you use it, but it works. It works quite well. Oh, right down here you can see too, another thing. This guide right here comes off, and you see it's for 0.025 to 0.035, so 25 1/1000ths of an inch to 35 1/1000ths of an inch. That's the size of wire that this backing plate is suitable for. I use my welder almost exclusively for welding mild steel, so that's steel pipe, plate, things like that. And you'll probably be the same too, but a machine like this is much more versatile than that, and then this chart shows. So we've got metal thickness here, and then we have the type of wire we're using and the different sorts of metals that we can weld. So this would be for mild steel. We have some stainless steel options here and aluminum with the right kind of gun. And you can also use this machine for stick welding, which is kind of just like a regular arc welder in that there's a holder that holds a welding rod, and that rod takes the place of the wire feed that you see down here. So a lot of variety, and in practice you'll probably settle down and just use a few of these. Typical thicknesses, 1/8 inch, 3/6 quarter inch, 3/16 quarter inch. That's probably what you're going to stick to. Most of the material that we want to weld in the home shop is like that. And it is a bit of a hassle too, to be honest, to change over. I mean, it could take me 15 or 20 minutes to change a kind of a wire. I don't want to do that all the time, but that's an overview of things. And now I'm going to give you a little welding demonstration, and I'm going to show you not just how the MIG welder works, but also the difference that gas or no gas makes to the results. So I did two different passes on this test chunk of steel here. The first pass is from here to here, and that's with shielding gas running. And you can see the weld is quite smooth. I think I would have liked better penetrations or better melting with the surrounding metal, but the bead itself is quite handsome looking, nice and smooth and solid. The second pass was from here to here, and I shut the shielding gas off just so you can see the difference that it makes. Now I actually started from this end, and I don't know if you noticed, but the sound of the arc changed as I went past about this point, because there was still some shielding gas in the hose, but when that was spent, there was just full-blown oxidization going on here, and we lost our regular sort of sound that we want to hear, the frying eggs, frying bacon sound here, and it changed to a much more spattery sound here. Now, there are some pock marks in the weld. This weld doesn't actually look as bad as I thought it was going to. It's not as bad as it sometimes gets, but it's not very strong, and it's because there's holes and gaps and little pock marks because of that oxidization that's going on. So there you have it. There's the basic MIG welding tour and an example of gas and no gas welding.